Thank you, Sarmaji. Good afternoon to all my colleagues sitting on the dais and off the dais. Just I wanted to tell you when we are talking about the coal gasifications, so sometimes it happens that people think we are talking something new. But if we see the countries like Mr. Rupesh has told that coal gasification is being used since long. But only thing is that where it is used. If we see that it was used earlier in Sasol, South Africa, they were the oldest. They were meeting all their oil requirement, all their energy requirement by this coal gasification only. But then China was almost similar place like we are. But luckily, their coal was slightly better than us. Our coal is having very high S content, varying between 35% to as high as around 50–52%. And that has become a bottleneck. Whereas China was having around 30%, 28%, 25%, and that took advantage. Today, if you see the Chinese industry, their petrochemical industries, their fertilizer industries, almost 80 to 85% have been shifted on coal gasification. Aluminum industry, everything has been shifted. And another thing, what morning one presentation was showing, 90 million ton of hydrogen is required. And out of 90 million ton hydrogen, around 20 million ton of hydrogen is required in China only. But China is the only country, if you see, most of the hydrogen across the globe is produced by 99% by steam reforming of methane. But China is the only country where around 14 million ton of hydrogen is produced by coal only. And if you see the cost is hardly anything. Coal to hydrogen is the lowest cost. But one thing you have to realize, coal is not having hydrogen. Coal is having carbon. It can give you carbon monoxide. But hydrogen, if you want to add, it is having a little bit moisture that can give you. But if you want 50% hydrogen, 60% hydrogen in gas or something like that, it means you have to adopt alternative means. And that can come at the cost of carbon monoxide. Because one molecule of carbon monoxide, if you want to have one molecule of hydrogen, almost same thing goes. And this results in production of carbon dioxide, and that becomes the problem. So this problem we have to see from the larger angle. Atmospheric gasifiers in India we are operating since long. Dev is the biggest supplier of this gas. And if you see high pressure and oxygen-based this thing gasifier, Jindal Steel Power Limited was the first company who took risk. Let us go ahead. And I think today we are the only company in the world, not only in India, across the globe, who is making steel using coal gasification. And JSP is the only organization in the country and few among the largest companies who are capturing around 2,000 ton per day of carbon dioxide also. Because if we don't capture carbon dioxide, we can't use those gases because we need carbon monoxide and hydrogen. So I thought I will just try to cover in this presentation about the case study, how JSPL has gone and where things are going wrong. Because we are setting a target that we want 100 million ton of coal gasification by 2030. Last 5 years, I was in the ministry as a director of Steel Research Technology Mission of India. We were pushing, let us push this thing. We should go for coal gasification. We should go for syngas. We should go for hydrogen. We prepared a report, coal to hydrogen. It is available in Niti Aayog document also, as well Ministry of Coal also. We identified that if we go with coal to hydrogen, we can produce only at around $1.18 per kg. Whereas on other basis, it is coming electrolysis. Today, $4 per kg, $5 per kg. Can we do this thing? But only problem was coming the CO2. What we should do CO2? Without carbon, you cannot live. Carbon is essential part of our daily life. Whatever you see, everywhere you need carbon. So carbon, don't consider it as a villain. Yesterday, like Mr. Arora was telling from Thapar, whether carbon is a resource or carbon is a villain. In my opinion, carbon, you have to see how you are treating it. If you can bring the principle of carbon recycling into your user system, then everything is resolved. Today, a lot of technologies are available. If you are having carbon dioxide, use carbon dioxide for producing methane. Use carbon dioxide for producing carbon monoxide. use carbon dioxide for dry reforming of methane. You use carbon dioxide for producing carbon. Australia is working, they have developed this thing, gallium-based liquid, which is melting point is only 100 degrees. If you pass carbon dioxide, immediately you get carbon flakes. Carbon flakes can be used as a carbon black. So we have to see where we have to attack. Carbon, if we can ensure recycling, this will serve two purposes. One is we can enhance uses of our natural resources. That is 330 billion ton, what Sarmaji has told, we have coal. What we will do? And second thing, we can be in a position to decarbonize our industry, that we remain competitive globally, so that nobody should say, we will put a carbon border tax on you of $100 or $200. So that we can do this thing. Some people talk about sequestration. Let us go for sequestration, whether sequestration is an answer, whether it is a long-term solution for us, where we are having a aquifer, where we are having a reservoir. So those things has to be seen. So whatever our practical solutions are available within our reach, in my opinion, we should try to see those things only. So if you see the gasification, as he has already told, what is three processes available? Gasification, pyrolysis, and combustion. If you put more oxygen or air, you will get consume all these things, combustion will take place. If you totally stop oxygen, you will get pyrolysis. But if you do partial injection only, so that carbon is not burnt and it remains in an intermediate stage, then it is a gasification. So there, we were trying to see that when carbon is there, its energy is converted into carbon monoxide and can be utilized, and that becomes a source of this thing. Some of the industry, like we are from the iron and steel industry. In iron and steel industry, only two reducing agents are there. One is the one is the hydrogen, and second is the carbon. But carbon is a reaction, exothermic, self-sufficient. Give little bit heat, reaction takes place, you produce iron and steel. Hydrogen, totally endothermic. Go on supplying heat. Hydrogen also supply, and external heat also supply. External energy also supply. That's why things becomes very, very costly. First thing is cost of the hydrogen. Second is the cost of this thing. So that's why today, in some of the conference, Sarmaji has told that 1 million ton steel plant, if we want to put on carbon base, it is only around 8,000 crore rupees. But if we want to put on a hydrogen base, it is 24,000 crore rupees. So 3 times is the cost. So whether this technology will see a future or not, how long it will take, that still depends on the time. It depends how we are going to produce this thing. First coal to hydrogen plant, when people were saying, recently commissioned in Australia, and they have shipped hydrogen from Australia to Japan, and they are claiming they have produced hydrogen at a cost less than $1. But they were having the sea. They could utilize this sea in the sequestration only. So that's why we could do it. We can also do that thing. Second thing, in my opinion, because the Indian coal is such, what Mr. Dev has told, that our coal is having poor washing characteristics. If most of the gasifiers, whatever we are having like atmospheric gasifier, we need coal of above 15 millimeter. Means what we should do with the low coal, means 1 millimeter, 2 millimeter, 4 millimeter. So Jindal Steel and Power Limited is also working in that area, that our technologies, whatever we are, constraints are there, we can overlook those things. And new technologies are coming, like coal briquetting is coming. If all the fines can be put into a briquette, then size becomes above 15 millimeter, and you can consume, you can optimize your resources there. So whatever challenges comes to you, then only you will find a solution. Unless a problem comes to you, you will not be in a position to think over it. Today we are thinking that we will convert carbon dioxide into carbon monoxide, re-inject into blast furnace, minimize fresh coal requirement. Convert this thing, coal briquetting, enhance resource efficiency. It will improve your circular economy, resource efficiency, and resource optimization. Because sustainable development goal is there, and that goal number 12 says responsible production and responsible consumption. Whatever we are doing today, everything has to be in that line only. We are answerable to the society. We are answerable to this thing. So this is simple application where we are saying that we put carbon, put it into this thing gasifier with limited amount of oxygen, and convert into our gases there. So there are 3 types of gasifications people are using. One is like we are using today, last one is the fixed bed gasifier. What he has already explained, what is fixed bed and there. Other options are there like fluidized bed is there or entrained gas is there. Entrained gas is there where if high, even this thing coal is there in a slurry form, we can feed the coal and put it there. But there, main problem comes about the slag and other things. Handling of those things becomes a problem. Today, only 2 countries are there who are using largely gasifiers, China and South Africa. Initially, there was a debate in 1993 to 1994, why we should go for surface coal gasification. What is the need? First, you do the mining, take out the coal, put it into gasifier, get syngas, get waste, again goes there. So instead of surface gasifier, can we go for in situ coal gasifier? Means there is no need of doing coal mining. There is no need of putting such equipments and other things. Just inject oxygen there, take out the gases, that is called in situ coal gasifiers. Somehow, that technology has been tried in Russia, 1 or 2 places, but other places is yet to be done. ONGC, around in 90s, they did one project for lignite, because lignite is having high moisture, but it is having low ash. So they tried to do experimentation there. They did lot of work, but after then, the gas price becomes very, very low. The project was abandoned. So time has again come when we may have to look whether surface gasification or in situ coal gasification, which direction we have to go. That also may be an answer which we may have to answer, question which we may have to answer even tomorrow also. So depending upon the coal, what we are saying is, unless you specify your coal, we have to improve our coal washing technology, coal gasification technologies. If we can improve upon those, coal gasification can be a boon for India. We can minimize our requirement of natural gas, import, everything, and we can be self-sustainable. So these are the benefits of the gasification. He has already explained. I will not touch more time on this thing, so I will just skip this thing. But if you see the cycle of the coal gasification, where we can go, everything you see, you can go from here. If you want to use for iron reduction, you want to use as a town gas, you want to produce ammonia and urea. So when we are talking about ammonia and urea, Sindri plant, Rajamundram plant, Angul plant, Talcher plant, so many plants were built with coal gasification technology. But somewhere technology has not responded well. Project was discontinued. But now when we are again reviving those projects, we have to learn lesson from our past, this thing, that we should not do that same mistake again. And when we are selecting a technology, so it should be properly scrutinized so that all aspects are taken care. Then another thing is coming, like we want to go to a jet fuel, we want to go to naphtha, then we want to go to methyl acetate, we want to go to polymers, entire chain. This entire chain has already been encased by Chinese people. And most of their industries are running on this basis, whether it is petrochemicals, whether it is fertilizers, whether it is iron and steel, whether it is ferrous metal, whether it is power. Everything is running on this basis only. And that's why their natural gas requirement, other requirement is very, very less. They have minimized their import, everything. But we have missed that bus. But now with the focus which is coming 100 million ton coal gasification, I think we should try to encash this thing. It is not only coal gasification for gas, but it is for producing all other liquid also, coal to liquid, so that these can come from there. If you see hydrogen, this what I have told, hydrogen we are using as a feedstock in refining, fertilizer, steel, chemicals. Except refining, China has everything converted into coal. Still refinery because they are using natural gas and naphtha, so they are producing hydrogen from there. Otherwise, all these 4 industries, fertilizer, steel, chemicals, and petrochemicals, they have converted into coal to gasification. And on other side, most of their things either running on bioethanol or running on this thing, energy storage, everything is going there. So this can be a good source. Another example, what Sarmaji has told about power. We are today using coal thermal power plant. What is the best efficiency? 38%, 40%. How much CO2 we are generating? Today, grid intensity of our electricity is around 0.85. It is one of the highest in the world. What is the grid intensity? Carbon intensity of the grid in other part, 0.4, 0.45. Our most of the CO2 emissions comes mainly because of the use of power. If we can start changing our philosophy, instead of going conventional boiler, if we can go integrated gas calorification basis, our efficiency can go as high as around 58, 60%. So it means 20% increase in efficiency, that much carbon dioxide you have already handled. You got more this thing. It is a better utilization of the resources. But hardly any plant is there in our country, but if you go in China, number of plants they have put on IGCC basis also. I think we can learn a lesson from them, and we can see in all future projects, instead of going just thermal base, which requires large amount of water and everything, can we adopt this type of process or not? So these are some of the reasons why now people have started talking about the coal gasification, that energy prices has gone very, very high. Availability of abundant non-coking coal in India, they are saying that when everybody is talking carbon, so we may be in a position to use only next 30 years, 35 years. After that, all these resources may become waste. So it's better to use as much as we can do in the shortest possible time, so that these can be utilized gainfully and to minimize our import bills also. Then coal is more evenly distributed geographically. Like oil is there, it is located only in western areas or northeast area. Whereas coal is available in eastern, central, other regions also. So we can make our industry based on this basis also. Then availability of now mature technology. Earlier technology was not there, but now a lot of technologies have come. But this has to be taken either from China, because they are the only persons who are using this thing. There is no other country. Other countries have developed technology, but they are talking, yes, this may be there, that may be there. But that provenness has to yet to be seen. Or we have to develop, if we want to develop our own technology to a commercial scale, it may take another 10 years. And by that time, we may miss the bus. So we have to see where to make a balance out of it. And last is, coal gasification is widely used in South Africa and China, and it is a success story there. There is no doubt that we cannot be successful in this area also. Only a focused approach is required. Like in iron, steel, I am just giving an example. Today, around 80 million ton of coal is imported in the country for making iron and steel, because we don't have coking coal. Should we continue with this thing? Why not we shift on the coal gasification? JSPL is the only plant in the world, as I told you, in India, but we face some problem because coal mines was cancelled, other coal was not good quality, and we were not getting consistency. Because in coal gasification, one thing is there, a consistency in the coal quality is very, very important part. If you start getting coal from auction today from this mines, tomorrow from that mines, you can never run a gasifier. A consistent quality is required. Some change in the policy government has already done, okay, let us allocate the mines so that the quality issue is not there. But then, thereafter, washability, all those things are coming there. But today, looking into the gas price and other things, I think coal gasification-based steel making is still one of the lowest cost steel producing method. If we can utilize this thing, we can be very, very competitive in the global market. Then similarly, we don't have the natural gas. People are using other part of the country, natural gas we don't have. That also we can handle that part. So with this, most of the industry, like iron and steel industry, is contributing around 12% of carbon dioxide emission of the India, 12%. And if we can start using this thing and make effective utilization of carbon dioxide by different methods, which are now available, I think steel industry can be a near zero emission industry, even with coal gasification also. So if people are saying that with coal gasification you cannot be near zero, I think now technologies are available and we can make it. So these are some of the selection criteria, what we need to select, but I don't think anything is there. These points have already been touched upon by them, my predecessor. So right now we are having around 7 gasifiers, and around 270 tons per hour is our early requirement, and these are one of the largest gasifiers across the place also. But just I wanted to show you some photographs also. You don't think that it is so simple. Coal gasification itself is a totally refinery or petrochemical complex. Just few photographs I will show you so you can have an idea ki how a coal gasification, what it composes of. Please next, please. So these are the things which I was saying. It is not only coal gasification. We are recovering sulfur as an elemental sulfur, selling into the market. We are recovering ammonia, selling it as ammonia. We are recovering phenol. Every part of the coal gasification. It is not only one gas. There are a number of byproducts are there, and these also helps in minimizing carbon emission in those industries also. So once we are looking for coal gasification, we should look for the entire solutions so that we are not damaging the environment, and at the same time, we are recovering all values where it is there. Next, please. So this is just look at plant coal gasification. It consists of like coal gasifiers, then gas cooling chamber, then gas liquor separation, sulfur recovery, phenol recovery, ammonia recovery, and the tank farm storage and other things. So it is just like a refinery or petrochemical complex. It is very neat and clean, no wastage, nothing is there. Next, please. This is some gas separation unit, gas liquid separation unit. You see how the plant looks like. No person is required, all fully automatic. No, nothing is required. Next, please. This is also another process for sulfur recovery. This is another unit of this gasification only. So this consists of number of places. Next, please. This is like sulfur recovery unit. Next. So now I was coming to the last slide is carbon capture and utilization. So we are saying that there are number of options are available, like CO2 through bioreactors to produce algae. Today, worldwide, there is a shortage of algae oil. And we are the country where we are having sunlight, we are having saline water. All the carbon dioxide, 1 ton of algae oil can consume around 6 to 7 ton of carbon dioxide. Only 2 things are required, sunlight and carbon dioxide. No other thing is required. Only thing is, lot of research need to be done, how to produce more and more different type of algae so that we can have high productivity algae from there. Another is like CO2 uses and bioethanol. Government has already given a policy that 20% bioethanol has to be mixed in petrol. And in future, it may increase to 30%, 40%. 2 ton of carbon dioxide can produce 1 ton of bioethanol. Whatever hydrogen is required in a steel plant, we can take out from other off gases and see how balancing can be done and convert. JSPL is considering putting up a first bioethanol plant of around 2 lakh liter per day on this technology only by utilizing these carbon dioxide and other things. Similarly, carbon dioxide to carbon monoxide. Our IIT Bombay, NCL Pune has already patented this technology. And these are world-class technologies where only at 200-degree temperature, carbon dioxide can be broken. Somebody feels that carbon bonding between carbon and oxygen is very, very, require high energy. Earlier, people were doing it at 800, 900. But new catalysts have been developed. With those catalysts, we can break it even at 200 degree. Energy requirement has become almost 1/3. So those are the things. Electrolysis of the carbon dioxide. You can produce syngas. You take carbon dioxide, steam, do electrolysis of the carbon dioxide. You require only renewable energy and get syngas. Syngas can be used everywhere. So these are the so many things there. Some students are sitting there. So these may be relevant to you also. You may be learning. So these are the new areas which are coming and people are working in this area. So we feel with this carbon circular economy, we can make iron and steel industry as a zero emission industry, and at the same time, with our own natural resources, means iron ore and non-coking coal, which is available in the country, so that in real sense, we are Atmanirbhar, and we are not dependent on anybody else. That's what my, thank you very much.